The rectangular coordinate system. So the rectangular coordinate system, you can see, consists of 4 quadrants. Now, in quadrant 1, you see both the x and y coordinates are positive, while in quadrant 2, the x coordinate is negative and the y coordinate is positive. In quadrant 3, both the x and y coordinates are negative, and in quadrant 4, the x coordinate is positive and the y coordinate is negative. So you always start off at your origin, which is the coordinate point 0, 0 right here in green, and then you move either to the right or the left based on the x value, based on the x coordinate value, and up or down based on the y coordinate value. So as you can see, if you're moving to the right, then x is positive. If you move to the left, x is negative. If you move up, y is positive. If you move down, y is negative. All right, so let's just look at a couple real quickly. We'll start with plotting the negative 3, 5. So I start at my origin, and I move 3 units to the left, 1, 2, 3, and then because it has a value of 5, I move 5 units up. And so that is my coordinate point of negative 3, 5. All right, for the next one, it says to plot the point 3, 4. So both of these are positive. So I know I'm going to be in quadrant 1. So I go to the right 3 and up 4. And that is the coordinate point 3, 4. All right, the next one says to plot the coordinate point negative 4, negative 2. So I know that's going to be in quadrant 3. I go to the left 4 and down 2, and I plot that point right there. Next, we have the coordinate point 3, negative 4. So I know that that is in quadrant 4, because the x value is positive, the y value is negative. So I move to the right 3 and down 4. The next one is the coordinate point 0, 4. So try to make it look a similar color. So 0, 4, that means I'm not moving left or right. I'm just staying at the origin and then moving up 4 units. So that's the coordinate point 0, 4. Now for the next one, we've got negative 3, 0, which means I'm going to move to the left 3, but then I'm not moving up or down. So that is my negative 3, 0. And the last point that I'm asked to plot is my origin, so the coordinate point 0, 0, which is right here. It is where both the x and y axis intersect. All right, so the next thing we're going to look at is solutions of equations. So equations in 2 variables have solutions x, y that are ordered pairs. Now, when an ordered pair is a solution, then when it is substituted into the equation, it results in a true statement. All right, so let's look at that for this one. For this example, we want to determine whether the following ordered pairs are solutions of y equals 4x squared plus 4. All right, so that means that my y coordinate would be negative 4. So I have negative 4 is equal to 4 times my x squared, so negative 2 squared plus 4. Now notice that I put that negative 2 in parentheses because that's representing x. So it is negative 2 that is being squared. All right, so what that means is I've got negative 4 is equal to 4 times 4 plus 4. In other words, negative 4 is equal to 16 plus 4. In other words, negative 4 is equal to 20. Now, that is not a true statement. Therefore, the coordinate point negative 2, negative 4 is not a solution. Now, for the next point that we want to see if it's a solution is square root of 2 comma 12. All right, so that means that 12 is the y value, so 12 is equal to 4. Then I put in parentheses my x value, square root of 2 squared plus 4. So 12 is equal to 4 times. Now the square root of 2 squared would simply leave me with 2. So it lets me drop my radical. So in other words, I've got 12 is equal to 4 times 2, which is 8, plus 4. So 12 is equal to 12. Now that is a true statement, and therefore the square root of 2 comma 12 is a solution. Now the next thing we're going to do is we're going to use an XY table to graph an equation. And in this case, we're going to use it to graph a parabola. All right, so I have y is equal to negative x squared plus 1. All right, so when I plug in that negative 3, that means I've got y is equal to negative parentheses negative 3 squared plus 1. All right, so that means I've got y is equal to negative 3 squared is negative 3 times negative 3, which gives me 9, plus 1. So y is equal to negative 8. So I've got the coordinate point negative 3, negative 8. And I go ahead and plot that point. All right, the next one I'm doing is I'm going to plug in the negative 1. So y is equal to negative parentheses negative 1 squared plus 1. So in other words, y is equal to a negative. Now negative 1 times negative 1 gives me a positive 1 plus 1. So I have negative 1 plus 1, which gives me 0. So at negative 1, I've got a value of 0, so that's right there. And now I'm going to plug in 0. So when I plug in 0, that gives me y is equal to negative 0 squared plus 1. So y is equal to 0 plus 1, which gives me y is equal to 1. So I have the coordinate point 0, 1. Now I'm going to go ahead and solve for when x is equal to 1. So when I do that, I get y is equal to negative parentheses 1 squared plus 1. That gives me y is equal to negative 1 plus 1, which gives me y is equal to 0. So I go ahead and plot that point. And then the last point I'm going to plot is x equals 3. So I have y is equal to negative parentheses 3 squared plus 1. In other words, y is equal to negative 9 plus 1, which gives me y is equal to negative 8. So that means when x is equal to 3, y is equal to negative 8. So I plot that point. Right, and then the last thing we have to do is just simply connect all of these points. So I start off. And there's my graph. Now the next formula we're going to look at is called the midpoint formula. So the midpoint of the line segments with endpoints x1, y1 and x2, y2 has coordinates x1 plus x2 over 2, comma, y1 plus y2 over 2. All right, so all you're simply doing is you're going to add the x values together, divide by 2, and add the y values together and divide by 2. All right, so for this example, find the midpoint of a segment whose endpoints are -4, -2, and 2, 5. For my x coordinate, that means I'm going to take -4 plus 2 divided by 2. For my y coordinate, I'm going to have -2 plus 5 divided by 2. All right, so -4 plus 2 gives me -2 over 2. And then -2 plus 5 gives me 3. So that'll be 3 over 2. And then I just simplify that to -1, comma, 3 over 2. The last thing we're going to do is the distance formula. Suppose that you have 2 points, P and R. So P has the coordinate points x1, y1, and R has the coordinate points x2, y2. And they're both on a coordinate plane. In order to find the distance between points P and R, you use the formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I want to find the distance between these 2 points, P and Q, what I can do is say, all right, well, I'm going to say what x1 is, what x2 is, and what y1 and y2 are. Now, it doesn't matter which one you say is x1, y1, and which one you say is x2, y2, so long as whichever x1 you have corresponds to the y1, so the y value for that x coordinate. All right, so I'm going to say that P is my x1, y1, so -2 and 2. And then for Q, that'll be x2, so 3 and y2, -6. All right, so that means when I use my formula, my distance between P and in this case Q would be equal to the square root of x2, so that's 3, minus the -2 squared, plus y2, -6, minus y1 squared. So that gives me the square root of 5 squared plus -6 minus 2, which gives me -8 squared. This gives me the square root of, now 5 squared is 25, -8 squared is 64. So I'm left with the square root of 25 plus 64, which is the square root of 89. Now this is my exact distance. If you are asked for an approximate distance or to round to the nearest decimal, then you'll go ahead and plug that into your calculator. And when you do, you should get approximately 9.4.